Today we're going to see how we generate models of electrical systems, how do we actually create them. And I want to show you a set of steps to be able to do them without making any mistakes. So let's take a look at the example that you see on the screen. And you're going to see that the very first thing we're going to do on these steps that I'm going to outline here is to recognize what elements we have. So we're going to say step number one, recognize elements in the system. So what we have is in here, we have recognize the physical elements that we have. This obviously right here would be like a source, source of effort in here in terms of the bond graph notation. This is going to be an R element over here. This too is going to be an R element. And this is going to be a C, obviously. Also, this would be another C element. How about this one? This is a measuring device. So it's either we have a voltmeter or an ammeter, right? So this would be like like a device that we will have a. This would be like we're going to measure the voltage. So this is going to be like an SF, but with current equals to 0, because no current needs to circulate here. It was just open. But we're going to make it just like a voltmeter. You see, a voltmeter is the high input impedance element, that's exactly how a voltmeter works. It means that you're going to measure the voltage, but the current that circulates through it is totally 0. So that's why I put a source of flow with the current equal to 0. Just to make that clarification before we get started. And this way the whole system has all the elements and nothing is sort of left with wires hanging in there, so that we won't be able to, so we'll be able to understand it perfectly well. So, and here you have step number 2, I would say, is to use a one junction to represent each distinct current. Distinct. Okay, so why don't we do that? We'll just put a one junction for each distinct current. Let's just do this would be current number 1, and this one would be current number 2. This would be current number 3. And even if this is 0, I am going to do current number 4, which we know is going to be 0. But I am just, for consistency, I am going to add to it so that it will help us build the bond graph without any problems. So in here I will say a one junction represents I1, just like the system is laid out in there. A one junction represents I sub 2. Another one junction represents I sub 3. And I would say this another one junction represents I sub 4, which we know is going to be 0. Okay. So this is the step number 2. We have done that. Step number 3 is going to be to, we're going to use, attach the elements that experience those distinct currents. Very good. So I'm going to switch colors in here so that we um, use the red to illustrate just the notation here. But attached to this, right here is the source of effort in here, which puts the like this, power into the system. As we go along, as much as we can, we'll define the power flow. In this particular case, this is a loop, but I don't believe that R1 sees I1. R1 sees I1 minus I2, but I2 is seen by this one though, R2. So I am going to put that one in here like that, R with value R sub 2 like that. This one sees the difference between these two, this two. This is going to be, on this case, it sees exactly the current, although it's 0. This is going to be a source of flow with velocity with current equals to 0, and then you may say, so this is going to be like this. But the question is, once we have a so no, I didn't mean to write it. Hold on for a second. Try it again. Source of flow is going to be like this. We'll determine later on about the idea of the half arrow here. We put for this one element that has one of the signals suppressed, we use this one in the middle. When you see the symbol, means one of the signals is 0. In this case, I sub 4 is 0. Yeah, let's leave it there. So we have attached the elements that experience those distinct currents. And then we're going to go to step number 4. Okay, I'm going to go and say step number 4 is going to be use 0 junctions to represent the current differences. And then parentheses, you could say those differences are also represented by one junctions. Okay, let me reiterate those. I will say those current differences. Those current differences are also represented by one junctions. Let's translate what I just said. In between I1 and I sub 3 is the C sub 1. So in reality, C1 sees the difference between I1 minus I sub 3. So I need to create that difference, you see. And the way I do it is using a 0. So this one in here that is created is represent this difference. I1 minus I sub 3 is also using a one junction. Okay. This C is I3 minus I sub 4. So I would do this, see? And this is going to be I sub 3 minus I sub 4. Very good. Between I1 and I2 also, you have this. But in this case, let's see, how do we represent this? I think it might not be a bad idea to just do it this way. I1 minus I2 is like this, I1 minus I sub 2. Yeah? And then you see we have finished step number 4, which is using zero junctions, indicate the differences. These two, there's 3 of those. All right. Now, what is step number 5? You will say at step number 5, I will say attach to those 1 junctions, here for the current differences, comma, the elements that experience those current differences. Very good. Let's try that. You see, in this particular case, it is R1 that experiences I1 minus I sub 2. So this one would have to be like this, see? This would be R with value R1. So we have that. We need this C1. C1 would be like this, with value C sub 1. And this other one too would be C with value C sub 2. And this one, of course, is in this. It looks pretty good, huh? I am here to announce that at this stage, you could enter this into CAMG and perform a simulation on this. You wouldn't, in that case, you wouldn't need to do the causal marks and the bound numbers, because CAMG does that for you. Another thing that is important to analyze here and to look here is that when you have it like this or like that, where you have a connection that has just the 1 or the 0, you could actually make a simplification. In other words, if you have it like this is equivalent to just this. Why? Let's imagine this, if this is 1 and 2. By default, the F flows are the same in a 1 junction, but also E1, you can say, and E1 is equal to E sub 2. So this is just like a through power, and the same thing is true for this one. If you have this 0 like that, this, let's put it like this, is this. It's not a bad idea to do it this way. So this would be like, if this 1 and 2, that E sub 1 is equal to E sub 2, but also that F1 is equal to F sub 2. So if that's the case, then this is equal to that. So the bond graph would get simplified. You can do all those things, but as far as the basic model and the way you would do it, in my opinion, in the easiest way and consistent way, is to enter this into the CAMG software right now. So I think we could try that and see how that is done. Or we could try also to complete the causal marks and the bond numbers and then enter it into the CAMG. So you have two options here. One, and I want to make it very clear, you have two options. One is you number the bonds and put the causal marks, and then you enter it into CAMG, or you let CAMG assign the numbers and you just, as you go along, entering the elements. Okay, in my opinion, the second option is more efficient because also you will not be making any mistakes as far as the assignment of the causal marks. So why don't we try that? I think I'm just going to go from here directly into the CAMG software. Like I said, you're free to number the bonds any way you want, and also CAMG will follow, go along with that. But I think at this point we need to enter this into the CAMG software. So hold on for a second. I think I clicked on the wrong icon. So we're gonna go over here. I think we need to perhaps make it in such a way that we reduce this a little here, the view of this window, yeah, like that, to be able to have it on its side in here and just work with it. Like this, and I'm gonna put it on the side over here. This is all we need. So what I want to show you is that in here you see you could start anywhere, but I'll go in here and I say this is SE1, and this process will not take long at all because now we are just translating what's on paper to our bond graph. And in here you see this is a 0 like that, and I would do a 1 over here, and instead of, well, I'm just doing it exactly as it's on paper. So put the R element over here and you have it this way, and then you put another 1 over, but you see what's happening? CAMG is assigning the power flow as I enter, and is assigning also the causal marks. So this is like that, and then I need to enter 0. It doesn't take very long. It's just very quick here. And we're gonna put the 1 junction over here and do this. And then of course the C element down here, and then there's this. And then we have the 1 junction over here, 0 to the 1. And then there's a few of these connections that can be simplified, but I am keeping them just as they coming because it will save us from redrawing the bond graph and the the increasing in time having a couple of more bonds. It's not really significant to change those things. This is interesting. One of them is in derivative form. According to this, didn't I mess up an element or so in here? And we'll see. It's gonna put this in derivative form. Okay, hold on. Okay, this is SF over here. Now we're gonna see this did not fix anything by assigning it to this. So see, this one is in derivative form, and that is okay. I think this is This is all we need to do. But in here, you could also represent this by the symbol that we had on the paper. See this assigned in here? This, what you can do is you say delete this. Okay, we're gonna go to the delete over here, and then we are going to put this one from here to here. There we go. And so this is the way this is assigned and drawn into CAMG.
Is there a reason why it's at node 13, it's making the C element in differential form?
Yeah, because you see in here the way the causal marks are assigned. See, the question is, why is C in derivative form? Now, this is an interesting situation because it lends itself for us to assign the causal marks in here and find out why. Okay, so why don't we do that? See in here, I'll just go ahead and in here let's just do the drawing here. Although one thing I want to say, we are done with entering the bond graph. So right now we're just going to do some extra thing in here just to verify that CAMG did the right thing. Okay, so I'm needing here to have this one. So here was assigned like that, right? And here we put it in integral form like this. It makes this to be like this, see? When this 0 is set like that, it makes this like that. And the moment it does this, it makes this like this. And when it does this with the 0, then the others have to be like this. And because of this 1, this has to be like that. And then, so because of this 1, this has to be like this too. So you seeing here, this one requires the integral, I mean one flow in, and sets the effort to these other ones, then all of these have to be like this. And the moment that this is like that, makes this like this, see? And then this, isn't what I have on the left hand side exactly what I have here on the right? See, take a look. It's totally the same. But what we find out why is because the moment this sets the effort here, it propagates the causality in such a way that made all the other ones to follow it this way to the point that the C became in derivative form. So this is in integral form. And this one is in derivative form. But that's, we have, I mean, by doing this little exercise, we basically verify that CAMG did the right thing.